Welcome to today's webinar. We will be today discussing about Windchill BOM management. So today's topic is bill of material management in Windchill, and this will be our objective. We will be starting an introduction to our organization. Then we will be having a couple of slides on digital thread. And after that, we will be going through detailed discussion on our today's topic, which is bill of material management, and in which we will be covering the BOM management overview and different types of BOM, such as the CAD, EBOM, and MBOM. And then we will also be having a live demo of the system, and in which we will be seeing how BOM management is done in Windchill. And after that, we will be taking up your questions. So let's start with this. I am 8+ years of experience in PTC Windchill, and my main experience starts with Windchill development. I have worked for more than 7 years in Windchill customization, and I am associated with boundary systems since April 2022. So as you can see, PDSVISION group has acquired our boundary systems organization since 2018, and since then we are officially now called as PDSVISION. We are technology leaders in PTC services. We are the first PTC global reseller and the preferred services provider. We also provide software solutions for design and manufacturing, and our capabilities include consulting, implementation services, professional training, cloud, and help desk. And you can also have a look at the map over there, which shows PDSVISION have got its presence in different parts over the globe, including North America, some countries in Europe, South Africa, India, and UAE. So these are our partners. The major one being PTC. We are also partnered with other organizations who provide solutions, software solutions, which support the PTC product, especially. These are Tecton, Moldex 3D, Xformation, Sigma 6, eShot, Itraj, ITI, and Symmetrics. Now, before going for our BOM management webinar, let's have a look at what digital thread concept is in brief. As you can see, digital thread is a closed loop communication flow, right from the product concept or planning to its actual physical product, and along with its delivery and services. So it starts with the first phase, that is as designed, in which a product is designed, or there is a conceptual idea of that particular product or its planning and in the sales. And then next comes the as build, which is the business processes such as BOM management or planning of the particular product, and then the actual execution of the production of that particular product or BOM or bill of material that we call. And then in the end, we have the as maintained, that means the delivery and the services related to this product. So digital thread serves as a good mechanism to have an optimized products and services. It helps all the departments or the roles contributing right from the planning of the product till the services and delivery. Everyone serving their purpose or role in this particular, from the each department has a single source of data, and hence they have the product services and the goods can be optimized this way. In the next slide, it shows the particular the innermost circle. As you can see, it shows our CAD data or the technical documents. It also considers the document management, CAD management, simulation. So that is the first phase, or the initial phase of the product. And then we have the business processes such as BOM management, change management, parts classification or project management, taking care of this particular digital data. And after which comes up the actual manufacturing planning of that particular product. So that comes in the third circle over there, which consists of the manufacturing processes or the ERP integration and other services. And in the end, everything is then connected with the IoT smart operations and products or the services related to that. So this is how the concept of digital thread is, and out of which today we will be going through the CAD, BOM management, and manufacturing process planning. So manufacturing processes. So this is the part that we will be discussing today with respect to BOM management. So before moving ahead with BOM management, let's look at the different parts and CAD objects that are being used in BOM management. As you can see, we have different icons that a particular object is being identified with inside Windchill. So for example, a part will be always identified with these gear icons inside Windchill, and similarly, the CAD documents will have their own icons or their own objects created inside Windchill, with which we will be able to differentiate between drawing or a 3D model, and so on, based on different CAD documents. So these are some of the icons. Then in the end, we also have this Word document sort of icon representing a particular document inside Windchill. So these are different objects that come along with OOTB Windchill, and which help in the BOM management. And these objects are then used to manage the BOM structure, bill of material structure, and inside a particular structure, and we can maintain them also with at every version. So they are all version controlled. Let's go ahead. And yes, these types are also we can also customize this type, or you can also have your organization level custom attributes to this particular type. So these can be then extended to support the company specific configurations also. Let's look at what is BOM management. So bill of materials management, that is BOM management, is capturing, configuring, managing of the product data that is being developed and managed throughout the life cycle, throughout its life cycle. So it is basically a structure representation of the products and its parameters, and they are maintained in such a way that they can be managed differently at different phases of its development. They could be at its developed phase or they could be at its release phase. So depending on that, we have a structure representation of that particular product inside Windchill. And that is what is called as bill of material, that is BOM structure inside Windchill. So the benefits of having a BOM structure is that it supports different types of structure for different departments. So today, as a CAD engineer, if I am looking at a particular BOM or a bill of material, I don't look from a perspective of a manufacturing engineer. So my idea of a bill of material is different. And hence, I would mostly generally work with the CAD assembly, which is generally the initial BOM or the initial CAD assembly is usually the first BOM structure for the product, but in some cases they could be from the part side also, or that is what we, or they are called as part centric. I'll explain that in further during the demo. So we usually start with the CAD assembly that a designer or engineer works on, and then with the help of BOM management, this CAD assembly will be able to have its own equivalent part structure assembly inside Windchill. So which is generally called as EBOM. That means E means engineering in it. So when we say as engineering bill of material, we are always talking about the design BOM. And this design BOM is usually a direct representation or an equivalent of a particular CAD assembly. And generally, the ERP system uses this EBOM, or you can, in most cases, some companies usually export that particular EBOM structure and use it in their ERP system. However, there are other companies who can also go to next level, that is an EBOM is then changed to the manufacturing bill of material. That is another version or the next transformed bill of material where the actual manufacturing department works on it. So that is called as the manufacturing bill of material. That means the MBOM. So these are the different types of BOM to start with, and the other BOMs is could be where we break down this manufacturing bill of material later on into different types of BOMs in Windchill. Could be service BOM, or they could be other plant specific BOMs also that we will discuss later. So what are the benefits of doing all this, right? One of the best benefit is that different department, such as the engineering or the manufacturing, have their own version of bill of material and they can work on it. So they can, when I say they can work on it, they can also have their own, changes to those particular bill of material separately. So a manufacturing engineer can make changes to his MBOM without disturbing the CAD assembly or without even disturbing the engineering bill of material. So in this way, we can maintain the change management and also ensure a traceability between the each type of BOM for a particular product. And then we also have a possibility where a BOM bill of material can have different type of data present in the structure, such as its related documents, its related supply chain data, such as the manufacturer part, the vendor parts. We can also have different component management, such as the alternates and substitutes maintained inside these type of BOM. So all this can be done separately inside an engineering bill of material or a manufacturing bill of material without disturbing the CAD assembly. Since these changes are more specific to the, not actually related to the CAD assembly, they can be maintained separately in the enterprise level structure of that particular product. And that is why BOM management helps us to differentiate between these data and managing them. So that means we can ensure change management and traceability also, and there is an improved component and supplier management also. At the same time, we have BOM transformation. BOM transformation means if we have an MBOM, Windchill gives us a capability to transform this EBOM to its equivalent MBOM using BOM transformation. Now, BOM transformation is usually a feature with the Windchill MPM link module. However, it helps us to maintain a traceability between the engineering and the manufacturing department's bill of material. The next thing is optimizing a downstream utilization. Eventually, because since we are able to have the manufacturing department planning their product right before or even before it is being actually executed, you can optimize or utilize the resources necessary for this particular M bill of material. That means for this particular manufacturing BOM well in advance. So that helps in optimization. And in the end, we can also create BOM-based reports. So you can also have different reports exported for CAD assembly or engineering bill of material or M bill of material. They could be in Excel sheet format. We can also export them to an importable spreadsheet. That means you can export it to an Excel. You can update that particular Excel, say you want to make changes to some of the components, its quantities and all. So you can work on that Excel sheet and then upload it to that bill of material. So it will be automatically taken care by Windchill, and the latest changes from the Excel sheet will be implemented in Windchill. So these are some of the benefits of having bill of material management inside Windchill. Let's move ahead and look at each and every BOM one by one, starting from the CAD bill of material, then to the engineering bill of material, and then the manufacturing bill of material. So the first one over here is CAD BOM overview. Now, what is a CAD BOM? This CAD BOM is usually the is the actual CAD assembly coming out of a CAD application such as a Creo or Pro. This generally represents a list of raw material sub-assemblies or quantities even needed to manufacture a product based on its drawing. Okay, so this is more on the CAD side. It has nothing to do with any enterprise level data as of in its particular bill of material, because it just represents the actual CAD model inside a CAD application. And it's generated within the CAD platform itself automatically in parametric platforms. So this is an overview, or the picture over here. It gives us an idea of how a CAD assembly would look like inside Creo. We have cycle.asm as the top node of the actual assembly, and it also has some sub-assemblies in it, which is the wheel.asm, which is another CAD assembly, another sub-assembly in it, which is a CAD assembly itself. So this entirely represents a CAD BOM to us. Now, the next one is engineering bill of material. Now, what is an engineering bill of material? We saw the CAD assembly, right? So whenever we check in or save this particular CAD assembly inside our Windchill from any CAD application, we are able to generate its equivalent engineering bill of material while doing so. So what does it mean? So if I am trying to save or check in, it's like check-in is usually getting the CAD inside Windchill, right? So when we try to check in a particular CAD assembly, for every CAD or every model inside that CAD, we can associate a WT part inside Windchill for it. So for example, in the picture, if you see cycle.asm can have its own cycle.asm part associated with that. And now this part, which is which ends with 709 over here, 000000709, this can be represented as the part structure inside Windchill, and this is called as the E bill of material. If you see over there, the icons over here, the gear icons show that it is a part structure. And you will also see that for each component inside the CAD assembly, we have equivalent component in the part assembly also. That means the EBOM also. So seat.prt also has its own equivalent part inside Windchill, and this part eventually can have its own data in which we can manage related documents. Those could be, say, specification documents. We can also manage supply chain data in it. So different type of data which cannot be directly associated with the CAD assembly is being taken care of inside the design bill of material. If you see in the picture, the view for that particular part, which is cycle.assembly 709, which ends with 0709, it shows that the view is designed. So whenever we are always talking about engineering bill of material, it is always supposed to be a design view. It is that is the basic understanding of engineering bill of material from Windchill side. And as you can see, it is reflecting the product as designed by engineering, and hence it is referred to as the as designed bill of material, and it's generally driven by CAD. But it can also be part centric. And what does it mean? It can be part centric. That means in some cases where an organization is more is a manufacturing organization, they do not have their own CAD models developed, they can start with a part structure directly inside Windchill. So you do not always need to have a CAD assembly to create a part structure. So you do not need to have a CAD BOM to create an EBOM in Windchill. EBOM can be directly created on its own as the starting point inside Windchill. And then maybe you can have any drawing from a customer associated with this particular EBOM. So that means it can start from a part structure. So hence it can also be a part centric. And yes, it includes all the substitute and alternate parts and all. That means the supply chain, the replacement objects in it, which I will be showing in the demo, and also supply chain data. So basically, it contains the enterprise data, which cannot go directly on the CAD assembly. So this is the EBOM, E-bill of material. Now let's go to what is M bill of material. So sorry, once we have an engineering bill of material, which is being designed by the business processes for a particular organization, if we want to have the manufacturing department also to have a look at it or to have their own views or feedback on it, say a particular manufacturing department is supposed to be involved during the BOM management process, we usually try to create a copy of this EBOM. So it's not actually creating a copy, but in simple words, we create a copy of an e-bill of material, and then we create its M-BOM, but with a different name. So this M-bill of material will be then managed or managed, restructured, or enriched by a manufacturing manufacturing department to make sure and plan for the actual product which will be executed at the shop floor. So M bill of material is usually the actual or the final BOM which will be manufactured by the manufacturing planning department, and it contains all the parts and assemblies design required to build a complete and shippable product. It can be it can be managed differently and can have its own change management. That means it can have its own changes or updates, information related to the shop floor, and you do not have to disturb the e-bill of material, the other design BOM. So in the picture, as you see, the left side is the design BOM, that means the E-BOM, and the right side is the manufacturing bill of material, that means the M-BOM. And you can also see that a particular manufacturing engineer must have restructured it to having two different sub-assemblies in it. So he changed the engineering bill of material structure, and he made his own. He added his own upper body and a lower body. That could be the way he will be managing and executing that particular product at the shop floor. So that having a different engineering, different bill of material for manufacturing department helps them to manage it differently, and it can then eventually also be configured to based on the different plant information. I mean, it can have a different type of information such as the raw materials, resources present at the shop floor, and they can M-BOM can eventually also be broken down into different plant specific views also. So you can also have different structures for one MBOM or alternate ones. So this is an idea of what a manufacturing bill of material is. Now let's move ahead and have a demo of what these different types of BOM look like inside Windchill. I'm going to connect to my VM. Start with that. Now this in the image, you can see that I have a CAD assembly. If you see this particular CAD icon of CAD assembly icon over here, which we have seen in one of the slides for a presentation, this icon represents a CAD assembly inside Windchill. Now, where did this CAD assembly came from? It came from the Creo. So if I don't know if I have this open, but this CAD assembly, let's go and first open it over here. Let's see. Okay, I'm going to open this here. So this is the CAD assembly that an engineer works on, and when he is done with all his changes and he wants to take this to the next level, to the next phase of the product after the designing is done, what he would do is he would go and check in the changes. So I've not done any changes to this, and this option over here is disabled, but we usually check in these changes inside our Windchill application. So once we do that, you will have this representation of that particular assembly inside Windchill. This is how it looks like. If we go to the structure, this is the CAD assembly right now, the first CAD BOM. And you can see we can also have visualization running over here, which will show you how it looks like in a small picture format over here. And for each node inside the structure, you can have a look at how it looks like in the visualization. Now this is the CAD assembly. When this CAD assembly came inside Windchill, we made sure that we associated it, or we created a part structure for this particular CAD assembly. Now what does that mean? So when I try to check in this particular CAD assembly, from here, when I have this option over here to, okay, I've done a checkout by mistake. Let me, I need to check out this. Okay, so when this cycle.assembly, when I try to check in this to Windchill, it gives me an option to associate a part to it and all the structure to it. So if you see over here, I was able to associate a part which is 0000709, and this part inside Windchill will represent or will be an equivalent of this particular CAD assembly. So if I go to the structure of it, now this is the view from Creo. I'm going to open it inside Windchill. And where do you find it? Since it is directly associated with this CAD, let's go to its related object. And in the parts, you will see the part structure that we had created. So if I go to the structure tab of this, so whenever we are dealing with BOM management, we always go to the structure tab here. And if that particular part has a structure, it will be shown over here in a tree format. As you can see, since this represents that particular CAD BOM, this is called as the engineering bill of material. That means EBOM. And if you see over here, the view of this EBOM is design. That means this is engineering bill of material because it is design. The next thing is, if you see, there are different tabs over here which helps us to maintain the information, updating of the information of this particular part. Now, if you go and look at each and every part, let's go to one of the component here, say this one, seat. This each and every part is having its own CAD model to it. So when we checked in that assembly for seat.prt for one of the CAD model, we had this part created inside Windchill, which is 000702 and associated with that. So that is why now this seed dot part, this part over here, Windchill represents this CAD model. And to this particular part, you can have its own data, such as the document, which I was telling during the slides. It can have its own describer document. It can have its own reference document, and all that data which you cannot directly go and put it on the CAD, right? So let's go back to the part structure now. I'm going back to the structure. Now this is how a part structure looks like. Let's go and see some of the icons over here. You can still go over here and add any levels to this particular structure using insert new and insert existing. You can, these options help over here helps us to revise, check out, check in. This option over here helps us to show all the information related to the engineering bill of material. That means this design BOM, EBOM. So if I select on all of these, let's go and select all these. I'm going to click on shift and select all of them. And if I click on show and say show all, it will show me all the data related to each and every part inside it. As you can see, it is showing me the CAD associated with each and every part over there. And it is also showing me different type of information, such as, I think we had a supply chain data also, one of them. Yeah, this test demo is one of the vendor part. No, this is the manufacturer part. So this is one of the manufacturer part that will be used for this particular component. So that information can also be seen in this view over here. You will have to make sure that we change the view while looking at them. Let me go back to this. Now this is part of AML data. You can also have different documents associated to that. So let's go to this particular sheet, and I'm going to add a document to that. So let's go in the view, view information, and I'm going to associate some document. Let's add a reference document or describe a document to this. And right now it's just a test document, so I'm not going to add any content, but let's have a reference document to this particular component. Finish. As you can see, I was able to add a document on that particular part without disturbing the CAD. I'm going to check in that. Now let's go back to the structure. I'm going to go back to my part number, which was 709, which represents our structure. And let's refresh this. And now you see we have the reference document coming in the view. So this view over here helps you to see all the related information for that particular structure. I will also go let you know about the AML and the replacement parts. So before that, let me first scroll through different options over here. We also have an option over here to compare this particular engineering bill of material. We are at this moment, please note that we are still at the engineering bill of material. We are not yet at the MBOM. Okay, so I can at this moment compare my part structure to the CAD structure. That means EBOM to the CAD assembly. So when we say compare to CAD structure, you can also have a look at how it looks like when we try to compare both of them. So this is how it looks like. So BOM manage, this feature can help you have a look at if there are any CAD objects, if there were any extra CAD objects which are still not able to, which were checked in but they were not having their part inside Windchill. You can make sure that you come over here, compare them, and if it is not, you can come and always add them. So this comparison helps you to build the CAD and the part structure equally. And I think this compare can also give you, let me go back. It can also give you an export of this. See, Oh, that's a different, okay. To have an export of your structure. Okay, so let's see how to get an export of this particular BOM structure. We are looking at EBOM right now, the design bill of material. I want to take a snapshot or a screenshot of this information right now, just to make sure that, okay, I have this cycle assembly, I have those many components in it, each and every component. You can also see that if I close this all, there are some sub assemblies inside these. One of them is, yeah, this is it. Yeah, back wheel assembly. If I click on that, you can see the uses tab. It always activates what all components are present inside a particular structure. So if I try to click on my cycle assembly, my uses tab over here will help me to see what all components are present, what all components are present below that structure. And if I want to look at sub-assembly level, I have to just go and click on it. So I'm just going to click on my back wheel assembly, and then my uses tab shows me that there are two components, which is a tire and a rim for that particular wheel assembly. So this is how the uses tab helps us to maintain the components. It also helps us to maintain the information of the components, such as the quantity, line number, reference designator, and so on. So it is basically the primary place where we manage the component level information. Now this is how we maintain the information of the component level. Again, let me go and tell you how we can even export this information. So yeah, so we also have two different options. We have an export option and we also have reports option. So in reports option, it can give you, it can help you get multi-level BOM report or single level BOM report. So if I click on multi-level BOM report, it will show me that my engineering bill of material, this EBOM, it looks like this. It starts with this structure, cycle.asm, and you see in the first column over here, it is showing the number. That means at which level a particular component is present. So for 702, it is present at first level. So it's basically a report of our structure of EBOM. And yeah, similarly, you can also have, you can also export this to Excel if you want. So you can go over here and simply export it to PDF or XML or Excel sheet. This is part of the multi-level BOM report. And when it comes to exporting, you can also simply export this particular BOM to, let me go and show you, importable spreadsheet. Now this is another interesting thing. If people don't want to work with the GUI, they can always work on the spreadsheet to maintain or update the BOM. So whenever I export, let's click on it. I'm going to export this. And when we try to export, you can also export to every part BOM structure level. I'm not going to export to the part level, just the BOM level information. And it can show you. So I'll show you how it looks like the part also. Let's see. I'm going to design that is BOM. So if I refresh this, let me copy and get this here. Yeah. And when we export it to the importable spreadsheet, this is how it looks like in the Excel sheet. Now this same sheet can be used to update that manufacturing bill of material. You can use this sheet if you go to the second one, which is BOM sheet, it will show you that 709 is the top node because it is at the 0th level, and then what all parts are located at which level. So 705 is the first level component, 706 is the second level component. So this is how it gives you the export of that particular BOM in this spreadsheet. And tomorrow, if you wish to change information in this, so I can come over here, and if I say that, okay, I want to change the quantity for 712, so I can come in this sheet, I can go over here, you can see the table for quantities. This is the same table which was visible in the uses tab. So I can come over here and change the quantity here. Let's change it to 5. Once I change it to 5, I can go back and import this spreadsheet, Excel sheet in my system, which will, if I go over here and just go over here and in our folder using the option import from spreadsheet. Yeah, we use that spreadsheet to browse and import it. It will automatically update the quantity over here. I'm gonna, let's see if we can do it. I'm gonna delete this because that is the part information. I don't want to update anything for the part. Okay, and if I go over here, from action importable, import from spreadsheet. Let's browse and get our latest file. I'm just gonna say update only. Next. While importing, it will also show you what are the changes. I think it will show me what change it would come up. Uh, sorry. Let's actually do that, finish it. Yeah, I'm gonna come back over here. Now you see that it has changed to A.7. It was earlier A.6. And if you go to the uses, I think the new quantity should be there. Looks like there was some issue. I had changed the quantity for 7.1. Where is 712? Yeah, 712 is here. I have to view it there. You see the quantity is now updated. So this is how you can use Excel to work on it. This is part of working with Excel and updating the BOM. Now, we are still at engineering bill of materials, right? I also would like to show you quickly one more thing before moving ahead with the MBOM. We were at show and show all information. And yeah, we were looking at the AML AVL information. So how does this information came over here? Now this test demo is nothing but another part, which is a manufacturer part, a supply chain part, and which is maintained inside Windchill. And go to this particular component and show you how I added that. So to maintain this information, we make use of AML AVL tab over here. And as you can see that I have added this test demo part, which comes from a manufacturing organization, which says an example like Hunter Inc. And similarly, you can have multiple manufacturing organizations set up inside the system. And you can go and just add that information over here. So that's how, this is the place where we go and add the AML AVL information. If I go, let's go back to our BOM. Now we saw the AML information, we saw the related documents, CAD documents. One more thing is the replacement parts. So replacement part, this one. So what does replacement part means? If I want to say tomorrow that for this particular frame, I need to have any substitute or alternate for this. So how do we maintain that? We come over here. Just a minute. And we come over here, and then I go to manage replacement. So this page over here will always help me to manage the alternates and substitute for a particular component. Now, what is difference between alternate and substitute? When I say substitute, I can have a substitute for this frame 2 only inside this cycle assembly, nowhere else. So for example, if I go and add a substitute part here, let's search for any part in the system. I'm just going to take the first one as an example. Now this test BR can today, if I click on OK, and let's show all the information. Show all. We were at frame over here. Let me close this. We were at frame and I added test BR. Now you can see it is represented by a different part substitute icon over here, right? It is a little blue colored icon. And this means that if this is a substitute, you can use test BR instead of 704, instead of frame, only inside the cycle assembly, but not in any other assembly inside Windchill, right? But when it comes to having a alternate, I'm going back to the same page now. And if I want to add an alternate for that particular part, so let's go and search for something. I'm going to get the second one. Now test BR2 is now an alternate for frame 2. And it also means that if frame 2 is used in any other assembly inside system apart from cycle assembly, it can still be used as an alternative. So this test BR can be an alternative to frame 2 if frame 2 is used in, say, part assembly 1, 2, 3, 4, which is not this cycle assembly. So this is the difference between alternate and substitute. But whereas substitute is that this rule only is valid for this particular assembly. And there are two different options, which is yes and no for alternate. So if I say two-way to yes, it means that test BR2 can also be replaced by my frame2.prt. So it is vice versa. I mean, instead of frame, I can use test BR2. And if test BR2 is used in some other assembly, instead of that, I can use this frame2 also. So this is what the two-way means. And if I click OK, I'll show you how this looks like inside. So if I open this component, to see that information, we always go to related objects. And there are two tables. One is for alternates here, and the other one is for substitutes. So this is how it looks like. We have a test BR, which is a substitute, and this second one is an alternate. And it shows two-way. It is showing two-way. So if I go to test BR, let's go to this information, this part. Let's go to that. And if I go to its alternate now, you will see, just ignore this. This is from other test data, but you will see our frame 2 can also be an alternative to this test part 2 because we made it to yes, two-way to yes. This is how alternates and substitute work. Go back to our EBOM structure. Where is it? So let's move on to the last topic here, which is creating, I'm going to check in this. There were some changes that we made. Now we need to go to our last topic, which is BOM, the third BOM, right? We saw the CAD, this is the EBOM, and now we are going to see the BOM. Now, how do we create BOM? So there are two ways of creating it. One of them is in actions. We go in actions, and in the new, we create a new view version of that. So what does a new view version means? That we will be having another BOM, which will be created for this cycle.asm, but it will be in manufacturing. The view that you give over here, it will be in manufacturing. So there will be a new BOM here, and it will have a manufacturing view, and hence that will be called as the BOM, that is M bill of material. Now this is one way of creating BOM. Let's go to the second way. This way does not need you to have the npm link module of Windchill, but the second way is where we use the BOM transformer. This one from the actions, we have open in BOM transformer. This option allows you to transform the EBOM to MBOM. That means create an MBOM from EBOM simply, but it also helps you to maintain the associativity. Now, how does it do? If I right click on this, on the left hand side, I have my EBOM. I have not yet created the MBOM. So let's right click on this, and I'm going to say new downstream branch. Now, new downstream branch, downstream is always for the manufacturing, upstream is engineering, that is design. So let's go and create a new downstream, that is a manufacturing. You see the view is also always coming as manufacturing over here. And I'm going to say there are three ways in creating this. So usually when we say do not duplicate, it just creates the top node. I don't want to do that. I want to also have the structure below it. And I also want to make sure that the structure below it is also in manufacturing view, right? So that it is a complete representation of our EBOM. So let's go with duplicate with propagating action. And if I click OK, yeah. Now you can see in the system, we have another BOM, right? And this is called as BOM. Now this is the third BOM that we were discussing, and our manufacturing department can take care of this BOM the way they want it. You can come over here, allocate some raw material. Say if I go over here, insert made from is for raw material. So I'm just going to go and add some raw material to this. So give that a name. But this is basically showing that you can maintain BOM differently, because now I'm just going to add, let's say, raw material, and let's view this. So I have to make sure that I show that information. Yeah. Okay, there was already one. I added one more by mistake. Let me remove that. So as you can see, I just added a raw material to this component inside the BOM, but nothing in the EBOM is changed. So this is how we can make changes differently and maintain it. This particular BOM. You can also restructure BOM differently. Not necessary that it should be the same way the structure is maintained in EBOM. If I want to have any bought out assembly, one of the main main function maybe the manufacturing department can use is that they can have a bought out assembly created for this particular BOM. So let's create a sub assembly under this cycle 709, which will be called as our bought out assembly. So I'm going to go and insert new. Now in Windchill, bought out assembly is being represented, is being set as a phantom assembly. Give the name as phantom. And to make this as a phantom assembly, you have to make sure that we have this attribute here. I'm going to click OK. As you can see, I have a new sub assembly being created inside the BOM, and the icon also, it looks a bit different than the others. because it is a phantom assembly. Now I want to make sure that some of these parts will be bought out. So I'm going to add them, restructure them inside this. So let's, for example, take these two and I'm going to drag them. I've just selected them and I'm dragging them inside this phantom assembly, you see. So wait, yeah. Now this is how we can restructure that manufacturing bill of material. And this phantom assembly can be then taken care by the, you can have another purchase order for only this particular phantom assembly later on from the ERP side. But this is how differently you can maintain BOM. I'm going to check in these changes. Let's check in. And I'm going to check in that. So you see, our EBOM is just not being exactly same as the BOM. If we were supposed to do these changes to our bill of material, it would have not, it would have also messed up this BOM, and also maybe we will have to take care of the equivalent changes on the EBOM, the CAD assembly side also. So BOM transformer, this window helps us to manage BOM, and it helps you to restructure, it helps you to restructure, enrich, that means we added raw materials, we made sure that we had a different sub assembly for the phantom assembly, and so on. So you can do these different changes for bill of material. This is how this is how the BOM management works from CAD to EBOM till bill of material. You can also have, I think you can also search these two. I'm going to close this now. And if I search for this part, you can also search them. Let's have this all right. In the system now, right? You see, there is one EBOM and there is one BOM present in the system. And you can work differently on them. I can make the changes for this because this is versionable object. The changes to these different versions and iterations for BOM can be maintained differently. The BOM that we created, you can come over here and look at it. Yeah, the phantom assembly added. And similarly, if I go to the second tab here, this is the design BOM, that is the EBOM that we saw. And if I go to the structure, the changes to these also can be maintained differently. So this is how the BOM management works in Windchill. And this is the end of our demo. I hope you found this informative. Let's go to any questions if you guys have. Let me know if you have any questions. If not, you can always reach out to us. I will wait for a few seconds if you have any questions. Okay, we can move ahead now. And yes, if you don't have any questions as of now, or if you have any more questions, you can always reach out to us. This is our website, PDSVISION.us. And this is my email ID. And my name is Radhika Bhagat. You can have my email ID over here. We also have our sales email ID over there. Anytime you can always check out our website to see other module related information. If you want to have more information on any other Wednesday webinar topics such as Creo or anything else, you can always check our YouTube channel. So thank you everyone for joining this call, joining this webinar today.